Good morning, good afternoon. Welcome to another VMware Tanzu webinar. We're happy to have you guys here for today's topic, Unlock the True Potential of Your Data Management Strategy with VMware GemFire. And today I'd like to bring in today's special guest who has presented with us before. Welcome, Charlie Black. Hey, Charlie.
Hey, how you doing today, AJ?
We're doing well. Thank you again for joining us. But before we hand it off to you, we do have a few housekeeping items that we'd like to cover. First, we'd love to keep this as interactive as possible. So if you have any questions for us, please submit them using the Ask Questions tab below, and we'll get to your questions throughout today's presentation. In addition, we know that you guys are here to hear from us, but we'd love to hear from you guys. So if you have any comments, any feedback, or what you'd like to hear at future events, future webinars, please use the Rate This tab also below the presentation screen. We do use a lot of your comments for planning out our webinar schedule. And we do take your comments to heart when you let us know how we're doing with today's presentation. So without further ado, send this off to Charlie.
All right, thanks, AJ. All right, so today talking about some data management with GemFire. So let's get into this. And what is GemFire, right? Oh, actually, let's do the agenda, right? So we're going to go through what is GemFire, some common usage patterns, how to code with GemFire, like what is that GemFire API, and then we're going to talk about resiliency in this talk, right? So what does that actually mean, and how to apply those concepts using GemFire to make your application development easier, right? So that way your app developers don't have to even know about some of these resiliency concepts because GemFire is just taking care of that for you. And then I threw in a little bit of observability just because I've been noticing it a recurring theme. So I just kind of threw that in last moment there because it is something there to think about on how to making a resilient application. Just making sure you're monitoring the full system, not just your applications, but like, your OSs as well. All right. So let's go on to what is VMware GemFire. VMware GemFire is an enterprise high-speed in-memory data grid, right, for high-performance, low-latency applications where your data needs to be consistent. So, like if I put a thinking about a banking application, I put $5 in, I'm going to get $5 out. So consistency is really key in the architecture of GemFire. And then those results are delivered in sub-millisecond response times, right? So we're going to talk a little bit about why GemFire can live up to that sub-millisecond response time and how to scale, not just within a data center, horizontally, vertically, but across multiple data centers, right? How to deploy GemFire in a global pattern so that way we can talk about the resiliency not just from a data center concept or a regional concept, but a global concept. All right. So let's get into some latency numbers that I'd like to make sure that we all understand when we're thinking about the performance numbers of GemFire and why I'm talking about the low sub-millisecond latency. So these numbers are so small that we're talking about on performance here that it's really hard to comprehend. Way back in the day, Grace Hopper did a nice presentation where she took these really small infinitesimal numbers and then converted it into something that somebody can understand, right? So what I'm going to do in this presentation or in this slide is just convert some of these small infinitesimal numbers into how fast do I walk, right? So we can get an idea for when I talk about quick, what's that relative term, right? So we have reading from a million bytes sequentially out of RAM takes about 2,000 nanoseconds. Reading it from like a solid state or NVMe drive, that's going to take about that same amount of data, takes about 39,000 milliseconds, right? And then reading it off of spinning Rust, that I don't know if you still use them, but if you do, that could take 718,000 nanoseconds, right? So these numbers are super small and tiny, but if we convert it into walking speed, it only takes about 7 minutes for me to read from RAM, 2 hours to read that same amount, 2.5 hours to read that same amount if I was going from solid state disk, and an eternity of 7 days, reading it off that spinning rust. So that gives you an idea for how I can make some bold claims on sub-millisecond response times. We're just that much faster. You thought your response times were good from your database. They're going to be way another league from GemFire. All right, let's go to the next slide. So another way that you can get GemFire to scale out is its shared nothing architecture. So when I start scaling GemFire to handle more reads and writes, right, everything's not shared. So as I add more disk, more RAM, more CPU, there's nothing shared. So that's another way that we get this near linear scalability. So as I add more machines, I can get just that much more scale out of adding another machine. And then another reason why we're using that RAM, we're changing up how the database internally at the GemFire uses like locks. Instead of using a disk drive to handle those lockings, we're using RAM, right? So just semaphores within your operating system. That helps us out with even getting another scale point on how fast things are. GemFire can use the disk drives. We can overflow RAM. We can reliably write to disk. We can do a whole bunch of things and use that disk in your architectures, right? And it's this very simple checkbox for your architect to just go off and be able to turn on persistence or overflowing to the disk drive. I talked a little bit about it, but I want to make sure I said this. Let's just say I was not able to handle some kind of load with the current system today, or I needed more storage capacity because I was onboarding more features into my application. GemFire is easy. You just throw another server on there. It can grow, and let's say we're a low point in the year or something like that. You could just shrink it. The application has no clue that anything is happening in the back end. GemFire is handling that all for your application. So there's no interruption with data service and no data loss. And that's the key for what we're talking about today, is making sure that your data is safe inside of GemFire. All right. So what are some of the common data storage patterns with GemFire? Well, you can use GemFire as a system of record, right? So we have the disk. You can just use GemFire as a database, right? It's a key value store, which we're going to talk about in a second. Some other patterns, since it is just an in-memory system, we can just use it as a cache. So I can do cache aside. I can also do read and write through, meaning I can use GemFire to help solve, like, let's say I had a data service in the back end of what's going on in the, like an API that I'm calling. And that API costs money. I can actually use GemFire to cache the results from there and prevent extra costs from happening. I could also do a write behind to keep GemFire from crushing a backend data system. There was a couple questions that came in. I'll answer them in a couple seconds, but let me continue on with this slide. So right behind allows me to make sure that I'm not crushing a backend system. There was a time I went for a services engagement where DB2 on the mainframe wouldn't keep up. So what I ended up doing was taking GemFire, putting that in front of the mainframe, so that way I could batch up all these transactions that were coming into the mainframe, and so that way they could save some MIPS. So we could do that with, Oracles, Postgres, or mainframes of the world. And then another common pattern is, the company likes to hold on to their existing data store. So, maybe we could just hot refresh the cache from their existing data store. What we're starting to see is there's so much data that customers are loading into GemFire. It's common to see terabytes of in-memory data grids now, and time to load that from, say, an Oracle or Cassandra could take hours. So instead of just transferring all that state, we're starting to see system of record use cases come ahead, and this hot cache concept just being a little less. Okay, so where can GemFire run? Well, GemFire can be deployed just about anywhere. It's very common to be, having a strategy where we have public and private clouds, where you're bursting up into the public clouds when you can't get that, you hit your limits on your private cloud. Running in hybrid, right? So you have one data center doing some kind of operations that are special, and then you have your public cloud being a different interface level, and then your historical store might be on private. We run on vSphere, bare metal, Kubernetes, Taz, all the places. Just thinking a little bit about Kubernetes. We're at all the hyperscalers, so we test with all the hyperscalers, so we can deploy to just about any Kubernetes implementation, including OpenShift. All right, next slide. I'm going to talk a little bit about how GemFire works, right? And I'm going to use a word called a region. And what a region is it's just a concurrent map which holds keys and values. So when you think about that's our main storage concept, you could actually just say GemFire is a key value store at the end of the day. So how does GemFire work? Hopefully this goes on. There it goes. So it has, two core APIs. We have a put where you can put your data into GemFire, and a get where I use that key where I stored things in there, and I can pull that data out of it. Now, one thing that I'm seeing, don't forget to look at looking at the example. GemFire uses objects, right? So one of the things of just using puts and gets might not be the best for all applications, right? So we have an ability to query these objects. So if you wanted to go off and query, we could actually do some really cool things. I don't know if my pointer will show up, but in this query, I can have a nice predicate. This is the for area. I'm going to use the for and the where. So in the region where I'm storing my data, I'm going to iterate through all the values in there. And inside each value, I'm going to have an array or a collection of positions. So now I can go through all my items in my region, look at a collection with inside of an object, and find out where people are finding things that have VMware. And I'm going to return not only that the value that was stored in the region object, but the actual position that was stored in that collection. So it's kind of interesting on how you can do applications and return good values out of there. All right. Another thing that you can do with GemFire is can be the central of event-driven architectures. We have a lot of ways to get change data capture out of GemFire. So you can do this from anytime you do a put, I can get notifications that something has changed. I can get it from a client, or I can run those in process in situ on the servers. Let's talk about a little bit about the client perspective. I can actually just get all events, or I can actually put a predicate on it where I am looking for some significant value. So let's just say I have some analytics and I want to be able to say, hey, once I get past a certain threshold, give me all the events that pass that threshold, right? So maybe it's a windmill and I've gone past some kind of wear indicator for my analytics. Now I can actually go off and say, hey, let's create an alert off of that. Maybe we need to send out a technician to that windmill and replace some part in there before it has a catastrophic failure. So really good stuff. Now the in process, that's where I can get some really cool scale, and GemFire will manage it for you. So this one, I can actually partition the workload across the grid and have what we call a competing consumer problem, right? Where Basically, you just have people working on partitions or shards of the data. It's a really powerful concept, and I've made some good architectures for customers when I was doing services work for the people. All right. So let's talk. This is where the heart of everything is. So thanks for sticking with me on just learning about some of the GemFire stuff. And let's talk about resiliency. And I'm going to talk about it from just general purpose terms, right? So let's think about resiliency in just the common sense of it all. If you think about it from a data center policy, right? There's n+1, 2n, 2n plus 1. All this is talking about is redundancy within the data center, right? Another thing that we're going to talk about is application policy, right? Number of copies that we want to store in the database, right? Is it 1, 2, 3? What's our fault tolerance from our application? Physical database policies, and then global, right? How's it going to look when I deploy this from a, one data center? Let's just say that there was a flood. Maybe I need to have it so that way I can survive, Charlie coming in there and accidentally knocking out the generators and the power centers, right? So we have to think about it not only from that local concept of a single data center, but also regional or global, right? And I'm going to talk about some of this stuff from a basic general idea, and then how GemFire can help you out with that. So OneNode, it's not a very common way to deploy GemFire. It can, right? There's nothing preventing GemFire from being deployed this way. I have a customer that does it, right? And they just like the GemFire API. And when they get to a point that they can scale, they can go off and do that and start having HA plans or better, right? So with this deployment pattern, you're assumed an outage, right? So if I need to update that OS, some library that my application is using within conjunction of the database, a virus checker, whatever it is that's running on that OS, it's an assumed outage. So if anything happens, hey, the database just stops working, right? Then your application's down, right? So if anything happens, your application's down. Well, when's the last time I backed that up, right? Like my little operator there made a mistake. When's the last time we made a big backup on there? We did remove .star, right? I don't know, right? So you got to make sure that you got a good ops plan whenever you do this, right? You have to make sure you practice things. You have to do like updates at night. A lot of scary things with single node out there. All right, let's talk about 2 nodes. This is okay, right? So now I have ability to be active while the system's being updated, right? I have an OS plan. Hey, I have another node up there. So I have my person taking one down, but now I'm at risk. If I took that one system down as my operators doing, yum update, will that person be able to handle it when the other system goes down for some accidental reason, right? We have a little fire on that machine, right? And then boom, my application's down, right? So there's a concept within fault tolerancy to have something more than just 2, right? 2 just gives me that high availability, but it doesn't give me that redundancy. There are concepts where you can go more than 3, but sometimes it gets into cost factor and you have to figure that out. All right, so let's talk about the 3 pattern. And, with the 3 pattern, it's okay to have one node go down, right? So, you're sitting there, operator comes in, brings the system down. At least I'm still HA at that point in time, right? So I'm doing my system upgrade. I got 2 more things out there. But what happens if I have a 3rd one, right? What happens if I have 2 instances go down at once? Maybe we should shift from that local data center plan to a regional plan, or better, right? So that way we can have that disaster recovery idea kick in. And then, I wanted to talk a little about monitoring. What's that operator doing? Hey, did he look at the dashboard and see that we had a nice, cute little dumpster fire going on? Right. So we want to make sure that we're not taking down the system when it was in a degraded state. So make sure that you're observing your GemFire. I mean, we're throwing alerts and all kinds of things from a GemFire perspective. I'm pretty sure those OS, those Dell racks, or I mean, those Dell systems were probably, hey, where did they go from the VMware console perspective? I'm pretty sure that there would be people alerts going off there. So you got to make sure your observability dashboard is actually working. People are paying attention to it. So there's his little fire fingers, right? Just causing all kinds of havoc. All right, let's go on to the next slide. So GemFire can help on this. I'm going to take a sip of water here. So GemFire can help on this by many ways, right? So from a data perspective, we have these two ways of specifying what a region types are. So we have this replicated. This one is data is on every node, right? It's good for like reference data or something like that. Let's just say I had a catalog, right? Maybe my catalog would be there and it's on all nodes. So that way the lookups are nice and easy, but I don't write to it that much because writing to say, let's just say you had a 16 node system. Do you really need that data on 16 nodes, right? I mean, you have to start thinking about the scale of it all, right? I have 1 terabyte machines, right? So do I need to put 1 terabyte of data on every machine? Well, that means I need to have bigger than that to make sure I don't run out of storage for my actual application. So replicated regions, it's not my favorite to start out with. I prefer to go with partition. And I might have used that word before. So let me define it a little bit more. So what a partition region is it allows me to spread the load, right? A lot of people know this is sharding, right? So I can shard my data across multiple nodes within the data system, right? So I can go off and say, have a redundancy factor. Let's not talk about redundancy yet. I could just spread my load over there. So, little sections of everything. So let's think about it from a terabyte perspective, right? So if I have a terabyte, then I can have 10 systems with 100 gigabytes each, right? So now that gives you an idea for how do I get up to a terabyte. I can just divide it up. Now, what I didn't talk about was a redundancy factor, right? We talked about a little bit about 3, and we talked a little bit about how we would want to keep that data safe. So a lot of times I like to talk about, let's make sure that when you're in that partition thing, let's make sure we have 3 copies of our data in there. So GemFire has the ability to say, from a policy perspective, of having your 1 primary, and then 1, 2, 3 copies of your data, right? I kind of like to think I would want just 2 copies, so you have your original and then your, two backup copies. Partition regions by themselves allows for scale. So, if I had that 10 node setup, I'm only writing to 3 nodes, right? So it's a little bit faster for writing, and GemFire will automatically restore redundancy when there's an issue. So let's just say I had one of those 10 nodes go down, GemFire will detect that and make sure the redundancy factor, whatever that was, is replayed, right? So now I have 9 servers, whatever that work that other server was doing will go off and automatically do that in the background. All right, let's talk about that from an infrastructure redundancy factor, right? So GemFire has this concept of zones, right? And what this zone can be applied to, and I'll talk a little bit more about in other slides, is it can be applied to data centers, racks, servers, large, like you have a large server and you want to run more than 1 instance on it. And if that server goes down, that's a big fault there. So it's just same thing as a rack or a data center. And then from another idea is this WAN, right? And then what the WAN is it, hey, I have a slower transmit time, right? So I'm going from East Coast to West Coast. So that's where we would start putting GemFire WAN in place. Typically, I would say whenever you have a latency between two data centers that's over 5 milliseconds, 10 milliseconds, somewhere where it's impactful on your application, then you want to start thinking about the GemFire WAN capability. All right, so let's see, how do we use those concepts that I just talked about in the GemFire perspective? So we talked about the replicated regions. So how do I make one, right? So, well, I just create a region and I say that I wanted it replicated. And then what GemFire will do is it'll spread that data across all machines. So if I have a fault in one of them, there's two more, right? In this depiction down here on the bottom, I have a fault, it's in the other ones. From an application perspective, do I even know that it's a replicated or partition region? No, I just do gets, puts, make queries on it. So you can almost separate the concerns from an application perspective and your DBAs, right? So your data architects or your data engineers are over there making sure your data is safe for your application concerns, and your application writers are just making queries, calling functions, getting events, and they don't even know what's going on because the policies are all handled externally. You don't have to do anything from an application perspective. That's the beauty of GemFire, right? Is it's just so simple to use, and it can get some really good, powerful stuff in the background, and all your application developers don't need to know about all this complicated, how is it keeping the data safe? All right. So let's talk about it from a partition perspective, right? So I'm going to go off, and I created a 4-node system here because it's a little bit more fun to talk about, because if I ever the redundant copies of 2, so you have your primary and your two copies, you know, if I only had 3 nodes, everything would be equal. So I kind of spread the data around, and you can see one of those servers had you know, 3 different things on it, and some were having 2, and that happens, right? You know, some nodes will have more data and some nodes will have less data, right? But the important part is when there is a fault. So when there's a fault, you know, a little happy fire, right? You know, maybe it's that operator accidentally did removed star on the root directory, or you know, did the yum update and things were not you know, the application started up and the server didn't start up because of, you know, some patch failed, who knows what it is. GemFire will detect that, right? Detect that outage, and it'll make sure that it moves the responsibility of holding that server's responsibility onto the remaining servers. If there wasn't enough capacity, you better hope you guys are monitoring GemFire, so that way it's sitting there throwing alerts. Hey, you know, if it was too much server, you know, you didn't plan out enough capacity, there will be alerts going off. Hey, we're at near capacity. We're running out of RAM. We're running out of disk. We're running out of CPU. So anyway, GemFire keeps it all safe and balanced, everything automatically and dynamically. So how would that look from an application perspective, before and during and after? I just do puts and gets. GemFire's happily doing things in the back end. Yeah, there might be like a little bit of a slowdown in when I do my get on one of those, that server, you know, like happened at the exact same time. There might be a little slowdown as GemFire retries. So it'll automatically retry in the background and then give you the right answer. Really good stuff. Applications don't even have to know about it. You know, you don't have to know about your failures. Yeah, eventually you're going to want to have some error handling in your applications, because let's just say that something drastic went down. Eventually you'll get an exception, right? So just like you would handle any remote procedure call or any other database call, you would want to have some kind of exception handling for those exceptional cases where, like, say, the whole cluster went down. Which that comes up with a question that somebody asked: what is a GemFire cluster? So a GemFire cluster is that where have the customers there? That's the whole cluster, right? Where you have all of the data servers there. And we also have a process called a locator. And a locator is like service discovery. So that automates the ability to find these servers when I dynamically scale a system. hopefully that helps out with that question. So let's talk about the infrastructure redundancy. So I talked about how GemFire has zones. Well, if we look at some of the hyperscalers out there, they also have this concept of availability zones, right? So AWS has availability zones, I think they regions or something like that, and they normally connect these data centers in with low latency resilient fibers, right? So they have more than one channel going back and forth. So that way, if you have an error on one of the channels, you get the ability to, still be redundant. Another thing that they do is make sure that each one of those data centers are in a different floodplain zone, different fire zone, whatever it is. Now, the one thing I would have to say about this is if you are thinking about zones from a GemFire concept, is the communication between availability zones is a little bit higher latency than within a single data center, right? So that should be somewhat obvious. It has to travel further, so you're going to get a little bit more latency in the network. But sometimes it matters for your data safety, right? So GemFire can handle it architecturally, same plans. It's just that if you're going for high throughput, sub-millisecond latency, well, sometimes the ping time between those two data centers might be 2 milliseconds. So you can't get sub-millisecond latency all the time, right? If you're starting to think about multiple data centers in your architecture. So I might have blown out this one, the next slide by already talking about it. So, I talked about the what happens there. Well, if we did have a fire, and the reason why I use fire is because I'm in our California wildfire season, is that data center could be out there. Well, GemFire has that concept of zones, which allows me to make sure that my data is safe. Remember, like in the partition region concept, I'm making sure the data is safe in each zone. So if I have a failure on that zone and I was maintaining my number of copies to be 3, then I actually had data in every single region. If I had 2 copies, then I was spreading it across everywhere. But it was at least keeping your data safe based on your architect's desire to keep the system up and running. So let's talk about a little bit more in detail of the redundancy zones. Maybe I should have had this slide earlier, where you get a picture of it, right? Of how GemFire can handle this. So the redundancy zone copies, right? You have zone A, zone B, and C. That kind of maps to AWS's zones, right? Or regions, zones. This could also apply to the racks. So you can call it rack 1, 2, 3, and then same thing with servers, right? So I'm running 3 nodes of GemFire because that's what I wanted to do, or, I wanted to control, like, this machine had a terabyte on there, and I only wanted to have, I can't think right now on how to divide that equally, but like, 300 gigs each in each one of them, just because that's what I wanted to do. Anyway, you can get the idea that it's just a label to us. So that's how you do it. Now, some of this stuff you have to, if you install GemFire standalone, you'd have to manage it yourself, right? However, with the Tanzu application or the tile that works on Taz, it's all auto-managed for you, right? So if your platform is installed with zones in concept in mind, that information on where those zones are come out to GemFire. So it's all automatically handled by the platform when you do the install of GemFire on there. So that's super awesome there. If you're using standalone, you do have to manage it yourself. So a little bit something to think about there. Kubernetes on that one, unfortunately, the information doesn't, where the physical is, does not bleed up through into the application space on Kubernetes. So whenever they get there, we'll throw it in there for the operator too. But that one's dependent on the Kubernetes area to get that good. We could do something with labels. in the Kubernetes space, but let's not talk about that. Just hit me up later, maybe in a conversation or through the feedback on the webinar. All right, so let's move on. I think I beat that one down to death. All right, so we hit a lot of concepts, right? And I might be throwing this out, or beating this drum a little bit too much, but what does it look like when I'm starting to do this zones and WAN and all this other stuff? Still just puts and gets, right? So from an application perspective, you can have a lot of complicated things going on in the background that is keeping your data safe, and your application's just flying it in, and just doing puts, gets, and the policies that you want to have over your data. GemFire is doing that in the background. Application writers are just sitting there doing puts and gets. Hey, go get me that customer. Go get Charlie. Charlie comes back. Oh, we had a data center go down. The application doesn't care. Your customers don't care that are using your application won't care. It's good stuff. Sorry about that. All right, next. All right, and then let's talk about infrastructure redundancy. So we had this concept of the availability zones on the hyperscalers, but what if it starts getting a larger delay between areas where it starts becoming impactful doing it right? We have this concept of a WAN inside of GemFire, and what this does is it allows us to go asynchronous. So I can start batching up information. So now when I do a call, that the aggregate of that latent network is now spread across all the puts, or a batch of objects that are going to go across there. GemFire can do this based on time, right? So hey, my application guys want to make sure that data is sent across every 10 seconds, 1 second, minute, whatever it is, because sometimes the failover for a data center could be a minute, right? So you can do it on time or number of objects, right? So number of events that have gone through. So that's really powerful to be able to configure that in those dimensions. And then we have two options, right? We have this serial gateway. And what that one's for is, you have a bunch of data flowing in. Charlie, Bob, Dan, whatever it is, all our data is flowing in, but it matters on which order it came in, right? So Charlie's order came in before Dan's. We want to make sure that that's serial, right? And that just, all that's saying is all events that are coming in are in thread ordering. Now, a parallel gateway, that gets us our big throughput. So now I get my near linear scale where I can saturate, whatever that pipeline is between the two sites. And that ordering concept is still there, except for now it's based on a given node within a system, right? So I can have a single data node come out there, and all the events are coming in there, and the thread ordering. I could have it based on keys, so that way it'd be like all the information for Charlie is coming out of that one pipeline, right? The red area where the little envelopes are. It's coming out of there all in thread order. So it's a really powerful concept in there for us being able to handle your data in a very safe way. All this stuff is also HA, right? So if that node did go down, there's another node that can go off and take over the responsibility. So really powerful concepts. All right, so let's talk about how do we do this, right? We talked about all these things that we could do, but how do we do it with GemFire? So slides didn't come out that good. I think it's just how the upload happens there, but we have my 3 sites, and I'm trying to use a WAN configuration here. So we have this concept of a gateway receiver, WAN gateway receiver, and sender. So I can set it up so that way I can have bi-directional. So you can set up senders and receivers on both sides, and then that's bi-directional. Or I could just set up senders on one side and or a receiver on one side and a sender on another. So I can just be sending data out. We could also, for people that have concept of what's that, GDPR, where, data sovereignty, there's also a concept of filtering on there. So I could actually filter out data that was not supposed to leave that area. I could actually filter that from going across the GUI. Anyway, lots of good stuff. We could probably go more in detail if you wanted to on there, but let's just talk about how do I set up basically, right? So all I do is I set up this gateway receiver. So that's the person going to be receiving data. And then I have a sender and I give it a name, right? So that's the idea. So create gateway receiver. That's me creating the receiver. Create gateway sender, give it an ID. So that way I can reference it later, because you can actually have it so that way some regions go across, the GemFire regions go across, some others don't. So I can have my customers go across, but my order is not, for whatever reason, right? So anyway, I just say what kind of gateway I want. Why not go parallel? Get that the high throughput in there. And then I say what site do I want, right? So I gave it a distributed system too, right? Whatever it is. And then when I go and create my region, I can go off and say, hey, where's my gateway sender? And then I give it the reference. So that's the reason why we have the ID there. I could also apply this gateway concept, right? Maybe I did my original deployment and now I want to go globally with it, East Coast, West Coast, Tokyo, Japan, London, wherever you want to go, you can get it in there. I can then do that after the fact, right? So I can go off and create my gateway senders and then alter the region and add it on later. So really good stuff. GemFire makes it really easy to do that. A lot of stuff there in text, but it's once you read the chapter in our docs, it'll become a little bit more sensible. And hopefully I made it clear what I was talking. And let's do the next slide, which I think I'm beating this one down to death here. What does it look like when I'm using WAN from an applications perspective? It's a get and a put, right? So the put would cause something to be put into the gateway queue and be sent across, right? But from my application perspective, they didn't even know what was going on. So I could have this application geographically dispersed. Same application, didn't have to know about it because GemFire is handling it all in the background. Really good stuff. All right. Let's go on to the next slide. And so we talked about monitoring. So I wanted to at least leave you with how do we do this monitoring? Well, monitoring from a GemFire, we're about as observable as you can get, right? So we can play with just about anything out there, JMX, Prometheus, and then we have this concept of GemFire stats. So one of the things that we actually can plug into is area observability, right? So you want to get a global distributed, good monitoring infrastructure, monitor everything. We plug into that. I've seen customers use Splunk, all kinds of systems out there. We can interface with it because we're using a lot of the good standards that are out there. GemFire Pulse is what comes with GemFire today for observability. And it's a pretty good tool, but we're going to replace that eventually with GemFire Management Console. So we have a new console that's coming out or came out this year, and we're going to be adding observability to it. So eventually Pulse is going to go away and the GemFire Management Console will replace that. One of the cool things about the Management Console is that it can, everything that I showed you, like creating all that text with GFish, you can do it through a UI now. And it'll walk you through it. So that way you don't have to even know those commands. Probably should have put that in the slide deck instead of the GFish commands, but oh well. All right. And then VSD. So VSD is a really, I'm going to call it the ninja tool, right? And what this allows you to do is we're always recording something, right? So in the background, we can write the statistics and the metrics and everything out to a file. And this will help out with, hey, I really wasn't monitoring my system. Or, hey, how do I call up GemFire support and show them my metrics when I can't even get a web, it's on a jump box and it's not on a WebEx or something that they can look at. Just upload this statistics files, which is written out for each one of the members. And we capture thousands of statistics on the system, right? So OS, how much disk drive space was it? How much was the network throughput that we're doing? What was the backlog on some socket, right? There's a ton of information that we're recording all the time in there, and it gets written to a file. So VSD is an actually really powerful thing. It looks a little bit old and clunky because it is a little bit old and clunky, but it works. So why bother changing it if something works just good enough, right? Gives you everything you need to know. Because you're probably using a Wavefront or Splunk or something, right, to monitor it in a bigger sense from a cluster or application or a bigger concept, right? Okay, so we went over quite a bit. So we discovered how to visualize the performance of GemFire versus other systems, right? That Grace Hopper stuff, really good stuff. Talks about, how memory is still better than NVMe drives out there. We talked a bit about GemFire, right? That you can actually just key value store, sub-millisecond response times, using that memory just to return as fast as possible. So get some good networks in there. And how to use it, right? Just concurrent map. You can also query your data. Really good stuff. And then we learned about the heart of this is how to keep your data safe with GemFire. Not only just from a data center or a rack or whatever it is that deployment pattern that you wanted, but how we did it globally, right? And then just because it's something that is near and dear to me, don't forget to observe the thing, right? I want to make sure that that's there for y'all. All right. So if you want to learn more, there's the gemfire.dev site, and from there you can go off and get your documentation, downloads, examples, blogs, videos, all kinds of other things. Here we talk about other things. And I think I'm looking at the questions here. I think we covered just about everything there. I can't think of anything else to say. AJ, I saw you pop in. You want to wrap it up?
Thanks, Charlie. I'm here back. Yes, so I do want to just say thank you again for today's presentation, Charlie. I do want to point out that we do have a big event coming for us for our business unit for VMware in total. We have Spring One and Spring One at Explore and VMware Explore taking place August 21st to the 24th. And I think looking at the content catalog, we do have a few GemFire sessions that we are highlighting during this event. Anything here you'd like to point out, Charlie? I know that you may not be presenting, but you may be on site perhaps. But if there are any questions, I'm sure people can reach out to you and any more insights you have.
Yeah, if I'm not going to be there, I know my colleagues are going to be there, and just stop by the VMware booth, and there will be somebody there that knows something about GemFire. You can ask more questions for them there.
Excellent, thank you, Charlie. I do want to just say thank you again for our today's presentation, Charlie. We always look forward to having you on. This will live forever as this has been recorded and will be available on demand. So if you couldn't get enough of Charlie here today, you can rewatch this session. Watch any older sessions with Charlie, and hopefully we'll have Charlie back on in the future. I'm sure we will.
Yeah, thanks, AJ. Yeah, and leave a comment if you want something special. I love hearing about making a special webinar for y'all instead of me making up things.
Excellent. Yes. So a great segue, Charlie. If you haven't already, please leave us feedback using the Rate This tab below. Let us know how we did or what you'd like to hear in future sessions, and maybe next time we can tailor this to what you guys would want to hear next time. Although I know that they loved what they heard today. So again, thank you, Charlie. Thanks to all of you guys. Have a great weekend. Bye all.
All right, thanks. Bye.